this is Aaron Kane doing Lab 5. I have to keep it down. I'm at the library. Thank you again for giving me a little bit of extension during my move. I really appreciate it. So, we are looking at butane here. So we have our 4 carbons, 1, 2, 3, 4. Now what we want to do is we want to look down a single bond. So we can kind of look down the single bond this way. And what we want to do is look at the energy associated with the bonds and the movement that they can make at the bonds. So what we can do is, if we're looking right down in the energy associated, as you can kind of see, if they are in line, if we can picture that those are in line perfectly with each other, that's what we would call eclipsed. So for example, if these were matching just like the hydrogens, let's say they were carbons up here, that's where you're going to get the most potential energy when you're in this eclipsed form. So these two at the top of our bonds are at basically 0 degrees apart. They're exactly lined up. They have the most potential energy between them because they're going to be the closest together. Next, give me 1 second, I'm going to set it down. If we were looking down the angle now, we just rotated. So this was our hydrogen before, this was the old hydrogen. So as you can kind of tell now, this hydrogen is right in between. So this is going to be our staggered gauge. So basically this hydrogen right here just rotated 60 degrees. So from this back hydrogen to this hydrogen, we're 60 degrees apart now. So that is basically the second most energy out of the group. And I'm going to go ahead and put it down one more time. Okay, so now we're back to our eclipsed form. Now this hydrogen back here, and the original hydrogen we're looking at is this one right here. So now we're looking from this one to this one. So now they're 120 degrees apart. So again, they're further apart, so less potential energy. So basically what you can do is, along these single bonds, this is constantly rotating. And as it's rotating, its position in correspondence down the bond is basically what's giving it its energy, whether it's here, or whether it's rotating around. And that's basically where you're getting all of your energy from, is those rotations. So that's it for Lab 5. See you for Lab 6.